Today we're looking at one-dimensional uniform motion physics. How I teach it is a little different than most books, so keep with me. I'm Ben, this is Physics or Bust. Most physics books that you deal with will have a whole sort of sets of equations. Each one of them you're supposed to use under one circumstance or another. My approach is to use 4 base equations, and then understand how some of the phrases used in the problems will tell you a variable and what it's equal to. For instance, if the problem tells you the object starts at rest, then vi equals 0. Or if it says that the object comes to rest, then vf equals 0. Another really common one is that if an object is falling due to gravity, then the acceleration is going to be negative 9.81 meters per second squared. Another phrase you might see is an object traveling at constant velocity. Notice that I didn't say constant speed, because if you have constant speed, you can still have an acceleration just with a changing of direction. But if it says constant velocity, that'll tell you 2 things. 1, that acceleration is 0, and 2, that vi equals vf, the initial velocity equals the final velocity, because if there's no acceleration, there's no change in velocity. One other common phrase you might see is that the object returns to its starting position, or at least some variant of that phrase saying that where the object started is where the object ended. And that'll tell you that the delta x, or d, depending on which book you're using, but I'm going to use d for displacement, that the d is 0. This can happen in one-dimensional motion when you have a positive initial velocity and a negative acceleration, or vice versa. What other phrases have you guys come across that tell you what a variable equals? Put that in a comment below, but make sure to include the variable and what it equals. Before I give you the 4 base equations, I do want to go through what variables I use and their descriptor. I use vi for initial velocity, vf for final velocity, a for acceleration, d for displacement, and delta t for change in time. Now that we have a basis for collecting information, a few organizational tips are in order. First off, I mentioned the 4 base equations, so here they are. Vf equals vi plus a delta t, vf squared equals vi squared plus 2ad, d equals vi delta t plus 1/2 a delta t squared, and the 4th equation is d equals 1/2 times the quantity vf plus vi times delta t. You'll note that with each of these 4 equations, out of the 5 variables, there's 1 variable that's not in each of the equations. That means that with the 5 main variables, you only have to have 3 variables with numbers in order to find the variable that you don't know that you're looking for. If you enjoyed this video, I think you'd like this book. I have an affiliate link in the description below. I do get a small commission, but it doesn't cost you any extra. So when you go to do kinematic problems, what I suggest is have these 4 equations written down, but also have a column where you write down the variable that's missing out of each of the equations, like this. Now before you start your problem, what I suggest is to write down your 5 variables right at the start. And then, as you read through the problem, you can write down what variables are being filled in as you go. Now let's get to our example problem. A hockey puck of mass 0.43 kilograms is sliding on a sheet of ice where the net force on the puck due to air and friction is 0.25 newtons. The puck is initially moving at 3.0 meters per second along the ice. How long until it comes to a stop? Now, writing down information that the problem gave us, we have the mass, which isn't one of the 5 variables, but it's a very common one that it'll give you, as well as force. So the mass is 0.43 kilograms, and the force that it tells you is 0.25 newtons. But keep in mind that since it's a friction force, that's going to be a negative 0.25 newtons, as long as we're also seeing the speed that it's giving us, 3.0 meters per second, as the positive direction. So those are the numbers that are given in the problem, but it also says in the question how long until it comes to a stop. That stop is telling you another variable, vf equals 0. So we have vi, we have vf. We can also find acceleration because it gave us force and mass. Since F equals ma, A is just going to be force divided by mass. So we have vi, vf, and a We're looking for delta t, so the variable of the 5 that's not involved is d. When we look at our 4 equations, the equation we're going to look at is Vf equals Vi plus a delta t. Doing a little bit of algebra, subtracting the Vi and then dividing by a, we get that delta t equals Vf minus Vi over a. So putting in numbers, we have 0 minus 3 divided by the acceleration, which our acceleration is going to be negative 0.25 newtons divided by 0.43 kilograms. When we put these numbers into a calculator, the negatives cancel out, and we end up with 5.2 seconds as our answer for how long it'll take for the puck to stop. Hope that helps you. Don't forget to like and subscribe, and remember, keep asking questions. I'll see you on the next video.